Okay, we're going to start here with Paul on the Plane video um, with a compilation of evidence refuting or presenting the possibility that satellites are not where and what they claim to be. So let's have a look.
Today we're going to focus on the Himawari geostationary satellite, which we're told is something like a mind-boggling 22,000 miles away from the Earth, sending us a real picture every 10 minutes. Did you know the Himawari ironically means sunflower? So, yeah, there's proof of the heliocentric sun worshippers model right there. So why are we picking on the Himawari today? Well, defenders of the heliocentric model love to point to the quote-unquote almost real-time images from the Himawari as proof of a globular Earth, since it allegedly gives us a picture every 10 minutes, and the weather data seems to be, pretty current. Well, unfortunately for the ballers, we're going to debunk that completely here, simply in the next 5 minutes, and show you how they fake it all. Let's cut right to the smoking gun to start. Here is the website anyone can go to and see this all for themselves. On a side note, the Himawari is operated by the Japanese Meteorological Space Agency and brought to us by the NOAA, the National Oceanic and Atmospheric Administration's GOES geostationary satellite server. And I'll include the links here for all this stuff in the video description, so you can check it out right now if you want. Okay, so when you're at the FTP site, click here for the site description. So when you do, a text file comes up, and you can see right here, they tell you that all of the images in the archive use the underlying colored land images from the NASA Blue Marble dataset. Yep. So the Himawari is actually totally debunked right there. These aren't real pictures coming from a satellite in a geostationary orbit above the Earth getting snapped every 10 minutes and being beamed down for us to...
Yeah, excuse me for a minute, Paul, but why would they need to overlay images or a data set onto anything? If it's actual images, why would they overlay it? So yeah, to me that's debunked right away.
All ooh and ah over. They take the Blue Marble data set, which I'm sure you remember. They admitted years ago was a flat strip data pieced together by an artist named Rob Simon in Photoshop, because it had to be, right? But to move on, and then to just briefly show you how they generate a picture every 10 minutes with what appears to be accurate in current weather. This is basically what they do. Now, don't take my word for it, as I always say. Go check it out for yourself. Number one, they have already created and stored transparent images of the weather over the oceans using climate simulation software, which they openly admit right here that they've done climate simulations up to the year 2095, but it's actually the year 2100 on this FTP server folder, and here's one of the images. And following some of the other images that you can find where the land masses are transparent, and they use all this simulation software to come up with the weather over the oceans. Since our weather data comes from our ground-based Doppler radar, and it's impossible to use ground-based systems to cover the entire vast oceans, so that's where the weather over the oceans comes from, their software simulations. Number two, now for the weather over the land, the NOAA has supercomputers that take data coming in from all over the world, Doppler radar feeds, and crunch it all together and combine it with the weather simulation data over the ocean, so they come up with a complete composite weather quote-unquote map, which is then wrapped around a ball in their 3D modeling software programs, just like we've shown countless times in our previous episodes with the Earth and the planets, etc. So then what we get are composite images like this that are created in the 3D modeling software, the current Doppler weather data over land and the simulated weather over the oceans, and it looks like this. So this particular image is on the FTP server and is date and time stamped with October 11th, 2017 at 11:05 a.m. I just chose one randomly. Notice the image shows you the weather for the whole ball and not just part of the ball that is lit by the sun at this particular time. No Terminator line or anything like that, right? Okay, now here's the kicker. Go to the other file folder, which is the images that we get to see and are told are real pictures from space. But what they've simply done is taken the weather map picture of the whole ball they created, and they superimpose it over the Blue Marble data set, just like they said they did. So what you can see here is the final version of what we're spoon-fed and told is a picture taken by the Himawari from space, 10 minutes ago. This is the image from the same date and time, October 11th, 2017 at 11:05 a.m. And you can see that the weather is exactly the same. Watch it closely.
So if you're going to refute this, you have to believe in super coincidences. So it just coincidentally matches up with the NOAA. No, I don't think so. And you could try and say, well, it's the same weather, so it's the same thing. Okay, but what about out in the oceans where the radars don't reach? Still matches the rest of it that ain't over the oceans. Genius.
There's your weather map comprised of simulated and Doppler radar being used to complete a composite image. They do this with the Discover satellite too, the Epic camera from 1 million miles away, they tell us. Ridiculous. Okay. Now, also notice the final image has a Terminator line added in to try and make it look like a real picture from space, which drives a nail in the coffin of the Himawari because the weather data shows it over the whole ball completely. But they have to add a Terminator line to show the Earth only partially lit by the sun based on the time of day that the photo is allegedly taken. So if this is a real picture, how did they know where to put the clouds and weather on the part of the globe with no sunlight? It's completely dark there. It's all right here, guys. They are faking space. Hey, we all fell for it for a long time with their Doppler radar and weather simulation software, building a current weather picture and wrapping it around a ball in 3D software and pasting it onto a black background like they do with all the others, adding a Terminator line and calling it a real picture from space. Himawari.
In this video, I'm going to do something a little bit different. I'm going to ask that everybody entertain the possibility that the data we get from satellites is not coming from where they say it's coming from. Could it even be possible? Okay, whether it is or it isn't, that's a separate video. That's a separate debate. But could it be possible that what people have claimed, that satellites aren't up there doing what they say they're doing? Okay, is it even possible? So let's take a look.
At altitudes exceeding 50,000 feet. This endurance and altitude makes Triton the only unmanned aircraft system capable of covering Australia's 8 million square kilometres of economic exclusion zone, as well as outer territorial islands, in a single mission. Based on Global Hawk, the United States Air Force's combat-proven unmanned aircraft system, Triton was developed by the US Navy to meet demanding maritime surveillance requirements. As the Royal Australian Air Force's MQ-4C Triton.
Now what I'm seeing here is hundreds of drones in one area. Also, I'll point out that it's a cartoon underneath. It's always the God view we get, or the satellite view, is always cartoons. Besides that, I see a network of drones, and from what I understand, they're a fraction of the price it even takes to launch a satellite. So I enter that in Exhibit A.
The system will provide an unblinking eye over the Commonwealth's maritime domain. Designed from its inception to work in partnership with a manned P-8 Poseidon maritime patrol aircraft, Triton will enable the RAAF to optimize use of manned maritime assets.
This is Exhibit B, and this kind of further speculates my hypothesis, but we know that technology from the military is kept, under reasons of national security, which is understandable, for up to decades. So is it possible that these are what was creating the images that they claim are satellite images? I think so, but let's watch.
The two pre-production air vehicles, also known as AV-1 and AV-6, were transferred from the U.S. Air Force to NASA Dryden at Edwards Air Force Base in September 2007.
So in 2007, they passed their hand-me-downs of something they already had, and who knows how long. Like I said, that's kind of speculating, but it's safe to say they had it for a while. And then they had probably the precursor to them drones even before that. So
AV-1 and 6 were among the first 7 produced under the original Advanced Concept Technology Demonstration Program sponsored by the Defense Advanced Research Projects Agency. As the world's first fully autonomous high-altitude, long-endurance unmanned aircraft system, Global Hawk can soar up to 65,000 feet for more than 31 hours at a time. It can also
65,000 feet. So the previous video we went over had a altitude capability of 50,000 feet, and at 50,000 feet they had a 300-mile radius, viewing radius. So this is 15,000 foot higher. So do the math. You're gonna have a way larger radius.
fly above almost any type of weather at any time, which means that measuring, monitoring, and observing remote locations of the Earth's surface are now possible. Under a Space Act agreement signed in April 2008, NASA and Northrop Grumman...
What? Space Act agreement? Did I hear that right? Space Act agreement.
will share use of the 2 early model Global Hawks, a new ground control station, and maintenance facilities. NASA will use the aircraft for Earth science and environmental research missions, while Northrop Grumman will conduct its own flight demonstrations for expanded markets.
So this is a website talking about the improvements over time of these weather balloons and what they're used for and whatnot. Just a bulk of information. It says in the 1930s that they vastly improved the data gathering capabilities of the weather balloons, and they started transmitting the data back to the meteorologists, like different, temperature, air pressure, humidity. So they transmitted the information right back to the weathermen. Okay, and then it says another development in 1958 allowed meteorologists to send semi-permanent balloons to a designated height and leave them there. So they would gather data over periods of time. So it says that they could reach greater altitude and be calculated to remain at that altitude for periods of weeks or months. So this is back in 1958. They were sending up high altitude balloons and leaving them there and stationary for weeks and months. Okay, then it says these could also be launched over water, which increased the amount of data that could be collected. Then these balloons transmitted data to satellites. So they just throw that in there at the end. You read the whole thing, but at the end, these balloons transmitted data to satellites. So now there's a middleman. So used to, the data was sent straight to the meteorologists, but they progressed. They progressed and started sending them to satellites instead of the meteorologists. So that's an indication of probably right about when satellites came into the picture. But they were already up there. They were already getting information. Okay, it was nothing new at the time. What was new was the satellites. Now this is Exhibit D, and this goes out to Blue Marble Science. Shout out to Blue Marble Science, who said that the balloons had to be launched on rockets to achieve orbit. But here you see NASA releases 2,366 kilogram super pressure balloon into Earth's orbit. So straight from the ground into Earth's orbit. See this? And this wouldn't be on the front page, okay? I got this link from Google way down past more results. They don't advertise this. You gotta, they do, but you gotta look far, deep and wide. But I also found, which I'm going to try and show this later in the video, how a cell phone company, LTE cell phones in South America, had blanket coverage from a couple dozen satellite balloons, Satelloons. Okay, so they just freely admitted that the cell phones we use were using satellite balloons and blanket coverage, and not even that many of them. But I'm gonna try and find that and post that later in the video. So if the Earth isn't a globe the way it's described, then where would we have problems? Where would there be conflicting information from satellites? I would say, obviously, below the equator in the south. And they would have to explain it to employees and other people. And here's a video doing just that. Look at that grid system. You see the grid systems the satellites use, a little bit different than before it's converted. That's how it looks initially, Cartesian. Anyway, let's hear an employee describe it instead of the video with the cool music. Let's hear it from one of the horse's mouths.
Despite our best efforts, satellites aren't always the most predictable. Sometimes they just up and reboot, or occasionally they misbehave for some unknown reason. As you might expect, these failures are a pain for scientists. Like, come on, we're trying to explore the universe out here. But if nothing else, we can take comfort in the fact that we at least understand where some of these errors come from. In one 1980s study, engineers made a map of where many anomalies happened for 2 satellites, and they found something really weird. The vast majority of them happened in a region above South America and the Atlantic Ocean. This region is known as the South Atlantic Anomaly, and it's one of the most dangerous near-Earth areas.
Not to be confused with the South Pacific Anomaly.
Areas of space for satellites and humans. The story of the anomaly starts with the sun. All the time, electrically charged particles from the sun's atmosphere stream off its...
It almost sounds like this guy's being sarcastic. I mean, listen.
Supersonic speeds. Some of that material zooms by Earth, and when it does, it interacts with our planet's magnetic field, because, well, that's just what charged particles tend to do. Some of the material gets directed into our atmosphere and causes the auroras, and some of it leaves the system. But most importantly for this story, some of that solar material gets trapped by the magnetic field and contributes to the Van Allen radiation belts, ring-shaped regions around Earth full of very high-energy particles. Despite the name, they're not actually radioactive. Space scientists use the term radiation differently than, say, doctors do. But in general...
Yeah, they use it, not really radiation. It's Van Allen radiation. Just like it's not really hot up there at thousands of degrees. It doesn't melt stuff. It just is that hot. It's just, this is almost embarrassing. But so I'm guessing that this guy asked questions, and this is the answers. You know, they got to respond with something. So this could even be, you know, questions he asked from people who paid money to get satellites launched up there, and they have the software. They hand them pretty much control of the satellite, but there's anomalies or things that don't match what they should. So when questions are asked, then they have to have some answers. And to me, this is my version. This would be a version of them answers.
Engineers would still like to launch satellites so they never encounter these belts, because those charged particles can pass right through a satellite's computers, causing hiccups known as single-event upsets. The particles can hit a computer chip and change its memory, basically flipping signals from on to off or vice versa. And that can cause anything from bad data to severe malfunctions or crashes. The problem is...
It's too good. So on, off, and just bad data. And yeah, okay.
Is depending on where you want to put your satellite, the radiation belts aren't always easy to avoid. Because despite what you might be picturing, they're not perfectly centered around Earth. They're a little skewed. Imagine you're looking down at the North Pole. You can start by picturing the belt as a ring around the Earth's equator. Now, push that ring a little closer to Earth on one side, near North and South America. Then tilt it a bit so it gets closer to the Earth near South America.
He just nudged it further and further until it got right over its mark of the continent of South America. It's so funny.
And a bit further away near North America. On average, that's what the belts actually look like. They're like this because Earth's magnetic field is tilted and shifted away from Earth's geographic rotation axis, meaning the magnetic...
So another shift. So another 66.6 degree tilt from the first tilt in the original position.
Magnetic poles don't line up with our geographic ones. Scientists think that's because the magnetic field is generated by Earth's core not rotating exactly the same as the rest of the planet.
So the Earth's core is supposed to be rotating with the planet over because of billions of years, and same thing with the atmosphere, but the core ain't quite spinning the way we're spinning. It's just somehow spinning in its own damn direction. Come on, man.
There's a region near South America, stretching from around 15 to 45 degrees south latitude, where the inner radiation belt is unusually close to Earth. Typically, the belt is at least a few thousand kilometers above the surface, but here, it's only about 600 kilometers up. That region is the South Atlantic Anomaly, and there, the inner belt is low enough to affect and damage satellites.
I'm not saying that there's not radiation up there in that spot, but I mean, for it to drop that drastically much lower than the rest of the thousands of miles up is in them to play that like it's just some small little area. That's a massive area because the ocean wouldn't even probably matter so much, easily explainable, but over the majority of the continent of South America, that's pretty significant.
Now, it might seem like the obvious solution is to just not launch satellites that pass over South America, but it's not that easy. For one, sometimes we want satellites there, but even when it's not necessary, it's really hard to avoid this region because of how orbits work. Orbits are symmetric around the equator, so if you want a satellite to pass over a certain latitude in the northern hemisphere, it will also have to pass over the same latitude in the southern hemisphere. So if you want your satellite to fly over somewhere specific, like NASA's facility in Maryland at about 40 degrees north, your satellite will also have to pass over 40 degrees south, right through the South Atlantic Anomaly. Because of this, low Earth-orbiting satellites often end up traveling through this spot for a few minutes every day. And as they do, they encounter those high-energy particles and the potential problems that come with them.
Them pesky particles. There them pesky particles are. But you look at the map of the Van Allen radiation belt, it doesn't show it anywhere near 600 miles above South America. But anyway, I could go on and on and on forever. I'll go for just another minute.
One way to protect spacecraft from this is to shield them with physical barriers. But since those can get heavy and therefore expensive to launch, we've had to find other workarounds. A common and clever one is to give a satellite multiple computers that can vote. For instance,
and there is the crux. So it's got multiple computers, so they're getting different signals. So let's be honest, okay? These things could easily be programmed. Easily. So if we're being honest on this, then we have to say that, yes, the data doesn't necessarily have to be coming from satellites. I think reasonable doubt has at least been presented.
You might have 3 computers all running exactly the same code, getting exactly the same information. And if at least 2 of them agree on an action, the satellite will do that. So if one computer glitches, the mission will be okay. This type of system wasn't invented just for the anomaly, but it still saves us a lot of trouble. But there's another problem too. Because we currently launch most equipment and crew from Russia and its high latitudes, the International Space Station also orbits through the anomaly. That's bad news, because high energy particles can damage our DNA. So as we get exposed to more of them, the probability of getting cancer and other diseases goes up. NASA attempts to limit astronauts' exposure to this as much as they can, and thanks to things like physical shielding and careful spacewalk planning, they do a good job. But if we didn't know about the anomaly, things could be a lot worse. Exploration would be easier if the rate,
Or it could be better, like it was for Bean in the Apollo mission. He said, yeah, well, we didn't know about the Van Allen radiation belts, so we just went right through them. Didn't harm us. Obviously didn't, because we went right through them if that's where they're at.
radiation belts were all nice and perfectly centered, but hey, that's not the hand we've been dealt. Instead, we've had to get creative with our engineering, and I like to think that that's made us better explorers. After
Creative with our computers, very, very creative with our software programs.
all, when we someday venture beyond near-Earth space, we'll have to deal with all kinds of particles like this. So at least we can figure out the basics close to home. Thanks for watching this episode.